We are discussing the modular arithmetic, and in the last lecture we have defined that what do we mean by a modulo n, and mainly that is nothing but the remainder when a is divided by n, and the three basic arithmetic properties, the addition, subtraction and the multiplication, and how actually they operates on the set 0 to n minus 1, since 0 to n minus 1 are the remainder when it is divided by n. So, we will now continue the discussion on modular arithmetic, because some more properties now we will read and some application areas that how that modular arithmetic we can utilize for some computation purposes. So, if we quickly write the just three basic arithmetic properties that we have read is the addition, I can write that a modulo n plus b modulo n, and if I take the modulo whole, this is nothing but the a plus b modulo n. Similarly, we have given the subtraction, and which is nothing but the same, only instead of plus we take the minus. This is minus b modulo n a minus b modulo n, and the multiplication that a mod n into b modulo n, take the modulo n which is a into b modulo n. Now, we take one example that how or how it is used for larger arithmetics, how it is what is the advantage of this thing. Now, we take one example. Say we take a equal to 11, b equal to 15 and n equal to 8. So, the addition will or a modulo n first we do, a modulo n is 11 modulo 8 which is 3. Similarly, I can write mu modulo n is 15 modulo 8 and this is equal to 7. Now, if we do the addition, we write addition, then 11 modulo 8 plus 15 modulo 8, this modulo 8, that means my LHS, this is my left hand side. So, 11 modulo 8 we have seen 3, 15 modulo 8 we have seen 7, 7 plus 3 modulo 8 is 10 modulo 8 equal to 2. And if I do a plus b modulo n, so if I write the RHS a plus b modulo 8, so this is simply 11 plus 15 modulo 8 and this is equal to 26 modulo 8, which is 2. Now, we see that here it is 2, here it is 2. So, these two are equal. Now, what is the advantage? See, here I have taken A is 11 and B is 15, but and this is slightly larger 26 modulo 8, I get 2. Here my computing I am doing only 11 mod 8 and 15 mod 8, not the, and I got 3 plus 7. So, instead of 26 I got 10. So, if my A is very big, say if I take my instead of A 11 and B 15, I can take my A is say is a very large number 1 0 2 3 5 like that, or even larger, and say B is also some 7 5 9 8 0 or even larger. So, whatever be the thing I do, when I do that A plus B, again it will be a some larger number, and that when I take the modulo, A plus B, so if whatever large number it is, if I take A plus B modulo 8, my the result will be only 0 to 7, because my modulo 8, that means only the remainder when it is divided by 8, the remainder can be only 0 to 7, and this is a big advantage when the large number will be dealing with large number, the computation with large number, particularly in the area of cryptography, the coding, that it is of tremendous use. Now, with the same number, that same example, that A is 11 and B is 15 and N is 8, we can see the multiplication, because all of we know the multiplication becomes the product will be even larger than the addition of 2. So, if I take the A modulo n, which is 11 mod 8 equal to 3, and my B mod n equal to 15 modulo 8, which is 7. Now, if I take the multiplication, that means A in LHS, again the similar way I can take the LHS, this is equal to the 11 mod 8 into 15 modulo 8, I take a modulo 8, and this becomes 11 mod 8 is 3 and 7, and this is modulo 8. So, 3 into 7 both are very small numbers, because that number cannot be larger than 7. So, at most this can be 49. So, this is 21 modulo 8 and this becomes 5. Now, if I do the RHS, then it is 11 into 15 modulo 8. Now, see 11 into 8, this is a larger multiplication, it is a complex multiplication, and the similar way if I take A and B, then it will be even larger. So, this will be 165 modulo 8, and if I take the remainder, this will be 5 because it is 20 into 8 plus 5. So, okay, 165 is this. So, I can write that 165 modulo 8 is equal to 5. Okay. So, when I am doing the multiplication, this advantage is even more because multiplication of two large numbers are actually a difficult computation, and this will be never, it will be more than the n minus 1, maximum it can be n minus 1. So, we see that these are, in this way we can take that this 5 and 5, these are equal. So, in this way we can take now exponentiation, because we know the exponentiation is nothing but the repeated multiplication. So, my exponentiation is nothing but repeated multiplication. And just now what we have seen, the multiplication is very easy, particularly large multiplications, multiplication of large numbers, because each one cannot be larger than n minus 1 when it is divided by n. So, we take one example of that and we see how we can take the advantage of modular multiplication. Say we are taking or we want to compute say 11 to the power 7 modulo 13. Okay. Now, 11 to the power 7, that means we have to multiply 11 7 times and modulo 13. So, what we can do that, see we have to compute this thing. So, I write my 11 modulo 13 is nothing but 11, because 11 is less than 13, remainder should be 13 only. But 11 square modulo 13, if I apply multiplication, that means it is 11 mod 13 into 11 mod 13, that of mod 13. So, I have to write each one will be 121 modulo 13 and that will be. So, if I divide that, what is my 121? 121 is 8, it is of 4 plus 4, okay, 13 into 9 into 13, I think this 9 into 13 is 117 plus 4. Okay. So, I can write 121 modulo 13 is equal to 4. Okay. So, 121 is 4. Now, I can 11 square is modulo 13 is 4. So, I can write 11 to the power 4 modulo 13, or first I take 11 to the power cube, 11 to the power cube modulo 13 is same as 11 square modulo 13, repeated multiplication 11 mod 13 and that of mod 13, just the rule of that modular multiplication. So, 11 square we have just seen that 11 square modulo 13 is 4 and 11 mod 13 is 11. So, modulo 13 and that is 44 modulo 13. So, this will be 5. Four into 11. Now, what is our I have to find out that 11 to the power 7. So, I can write 11 to the power 7, okay, if I can 11 to the power 7 can be written as 11 to the power 7 is 11 to the power 4 into 11 to the power 3. So, 11 to the power 4 we got 3, we got 5. So, and 11 to the power 11 square we got 4. So, that again I can write 11 square or I can find out the 11 to the power 4 only. Okay. So, I can write the 11 to the power the same way I can write the 11 cube. So, 11 to the power 4 modulo 13 we have to compute, that we can continue. Okay. 11 to the power 4 modulo 13, that we can write 11 modulo 13 into 11 or 11 cube modulo 13 into 11 modulo 13 and mod 13. And 11 to the power cube we got 5 into 11 modulo 13 and 55 modulo 13. So, that is 3. So, now if I write 11 to the power 7 modulo 13, I can write this as 11 to the power 4 modulo 13, 11 to the power 3 modulo 13 and 11 to the power 4 is 3 and because this is my multiplication rule and this cube is 5. So, 3 into 5 modulo 13 and this becomes 2 modulo 13. That means, this is equal to 2. 2 modulo 13 is we get that when remainder is 2. Okay. This is 2 I can write 2 modulo 13. Now, see the way we have done this power can be is a large number, that it can be some, I can write some a to the power b and modulo n, where these a and b are very large number. A and b are large integers, say very large integer. But if we apply the modular multiplication to compute the exponentiation, then never the each modulo multiplication result cannot be larger than n minus 1, because that remainder can be only n 0 to n minus 1. So, in this way if we compute, my computation is much simpler. So, this is one particularly to get exponentiation, that this is a big advantage, and this is used, this computation is used in cryptography. Some algorithms like RSA algorithm, we know that public key cryptography, this has a big advantage. Now, we see some simple properties of modulo n, or before that we define a congruence, which is actually some I should tell some variant of modular operation. How we can define the congruence or congruent modulo n or congruence? So, if a and b are two integers, a b are two integers and n is a positive integer, and where a and b are divided by n separately by n, and modulos are that we can write it is a modulo n, and when it is b is divided by n, the remainder we can write b modulo n. Now, a modulo n, just now what we have read, the remainder can be only value 0 to n minus 1. Similarly, b modulo n, whatever be the value b of b, this can be 0 to n minus 1. Now, since if n is small or whatever be the n values, then it is a many to one mapping, that means for many a and b that will map to the same value, because a and b can be any larger integer that we can get the same value n. So, if we see that my a modulo n equal to the b modulo n, that means the remainders are same when a is divided by n, b is divided by n. Then we write that a is congruent to b mod n. So, this is the definition of congruence. A is congruent to b mod n when a mod n equal to b mod n. So, we call this is the operation of that congruence, and we write a is congruent to b modulo n. Okay. Now, we see some property of this congruence. So, property 1, again these are also properties of, I can tell the modulo operator, because congruence is nothing but the modulo. So, again we read some of the properties of modulo operator. So, many times we define or the property that if a mod n equal to b mod n, or I can write a is congruent to b mod n, same thing just now we have defined, then n divides a minus b. Sometimes this is also one definition of the congruence we write, that n divides a minus b. How we can explain this thing? See, we start from this, that I can write the proof or explanation, whatever we call the proof or some explanation, because it is trivial. Then if n divides a minus b, that means a minus b equal to k n, because there is no remainder, k is the quotient. Okay. k is integer. This is the quotient. So, a equal to b plus kn. Now, this equation if I divide by n and take the remainder. So, divide the equation by n and take the remainder. So, remainder will be a, the LHS will give a modulo n, and if I divide it by n and take the remainder. So, kn, since I am dividing by n, so kn this portion has no remainder because it is n divides kn because it is divisible. So, I will be getting only b modulo n. So, which is my definition, or what the statement tells, that if a mod n equal to b mod n, then n divides a minus b. So, this is one property that we many times we use that thing. Now, other property I can write that this is very trivial, that if a is congruent to b modulo n, then we can write b is congruent to a modulo n. Okay. And the explanation is very, I should tell explanation instead of proof, because it is mainly coming from the definition of modulo, that the way we have done, that congruent is a mod n equal to b mod. B mod n. So, I can just write this side b mod n equal to a mod n, and this is the definition that b is congruent to a modulo n. It is very trivial. Now, the third property, that property 3, we can write that if a is congruent to b modulo n and b is congruent to c modulo n, then a is congruent to c modulo n. So, I think again this explanation is very simple, because a is congruent to b mod n means a mod n equal to b mod n, and b is congruent to c mod n is b mod n equal to c mod n. So, I can write a mod n equal to c mod n, and which implies actually a is congruent to c mod n. So, these are some of the properties, that if we see some example we see that, okay, example we take 23 is congruent to 8 modulo 5. Minus 11 is congruent to 5 modulo 8. Similarly, I can write 81 is congruent to 0 modulo 27. So, if we explain that first one, 23 is congruent to 8 modulo 5, because we see if I here n is 5, okay. I can write, give some 1, 2, 3 and better I write the explanation. So, number 1 explanation is my A equal to 23, B equal to 8 and n is 5. So, what we see that 23 modulo 5 is 3 and 8 modulo 5 is 3. So, from here I can write that 23 is congruent to 8 modulo 5. Now, if we see the 2, that minus 11 is congruent to 5 mod 8. Directly I can write minus 11 modulo 8 is minus 3, and minus 3 we know minus 3 is nothing but plus 5. So, I can, since it will be a positive number, normally that is the convention. So, one thing you note that if it is a minus, then and if it is modulo 8, so if I get x, then it is that n plus x. X is, if x is minus 3, if it is negative, or then it is n plus x, that means 8 minus 3, 5. And 5 mod 8 is 5, because 5 is less than 8. So, 5 is the remainder only. So, from here and here I can write minus 11 is congruent to 5 modulo 8. Then similarly, the 3, if we see 81 modulo 27 is 0, because there is no remainder. 3 into 27 is 81 and this is 0 only. So, I can, and 0 modulo 27 is 0 only, because that divisible property or divisors, property of divisors we have seen that any b not equal to 0 divides 0. So, this is the property, very trivial property. So, I can write 81 modulo 27 or 81 is congruent to 0 modulo 27. Okay. So, 81 is congruent to 0 modulo 27. So, congruence is actually one property of modular arithmetic. So, these are some of the basic properties of modular arithmetic, and again we will see some examples or other modular properties when particularly the addition and multiplication we will see. Division now we will not consider, and slowly we will see that what is the problem or how we can incorporate the division properties. So, next lecture we will continue again with the properties of modular arithmetic, in particular the addition and the multiplication operation.